One day, your life may depend on a stranger's blood. Whether that blood can save you was decided long before the emergency ever happens, written into your cells at birth. In a trauma room, in childbirth, in surgery, compatibility is not a preference, it is biology. Your blood type determines who who can help you, and how much margin for error exists when seconds matter. Let's break down what those letters, A, B, 0, positive, negative, actually mean. The positive or negative refers to the rhesus factor, a protein on your red blood cells. O, negative. You're in a car accident, you're bleeding. Your blood type is unknown and time is running out. When doctors cannot wait for lab results, they reach for O negative. It accounts for only about 7% of the global population, yet it is used in a disproportionate number of trauma cases because it can be transfused to patients of any ABO and RH group. This compatibility exists because O-negative red cells display neither A nor B antigens and lack the RH factor. Without these markers, the likelihood of an acute hemolytic transfusion reaction is significantly reduced when the recipient's blood type is unknown. That is why O-negative is regarded as the universal red cell donor in emergency care. The flexibility works in only one direction. If you have O-negative blood, you are the one who can receive red blood cells only from the same type. In well-equipped hospitals, this is manageable. In large-scale emergencies or regions with limited supply, availability becomes critical. There is also an evolutionary explanation for this distribution. Blood type O-negative carries a very ancient genetic heritage. In the world of genetics, Europe is a unique cluster. While O-negative is rare globally, nearly 1 in 7 Europeans carries this trait. The Basque region stands out as the ultimate global hotspot, with up to 35% of the population being rhesus factor negative. Evolutionary biologists view this as a genetic echo. The Rh negative factor was likely a core trait of Europe's ancestral population. In regions like the Basque Country, this ancient signature remained remarkably intact due to limited migration over millennia. Today, this heritage is a vital gift to medicine, as O-negative serves as the universal donor type, saving lives across the globe. O-negative is rare, medically indispensable, and dependent on a limited donor network. In emergencies, it stabilizes others. If you have it, you rely on that same scarce supply. O-positive. You're at a blood drive. You roll up your sleeve. O-positive is the most common blood type worldwide. Roughly 37% of the global population belongs to this group, making it the largest category in transfusion medicine. Its red cells express neither A nor B antigens but do carry the rhesus factor. This allows transfusion to any Rh-positive recipient, regardless of whether that person is type A, B, AB, or O. Since about 85% of people globally are Rh-positive, O-positive covers the majority of routine transfusion needs. In many hospital systems, it is among the most frequently requested types. From an evolutionary standpoint, O blood types show a protective association against severe malaria. The parasite Plasmodium falciparum is less able to trigger the formation of rosettes, clusters linked to severe disease outcomes. This may help explain why type O is highly prevalent in malaria-endemic regions. O-positive is common, widely compatible for Rh-positive recipients, and central to everyday clinical practice. Its prevalence helps stabilize global blood supply systems. AB negative. You carry one of the rarest blood groups worldwide. Fewer than 1% of people carry AB negative, making it one of the least common ABO and rhesus combinations. Red cells in this group display both A and B antigens, but lack the rhesus D factor. As a result, recipients can accept red blood cells only from AB negative, A negative, B negative, or O negative donors. The compatible donor base is small, which makes supply consistency essential. The plasma component tells a different story. Because AB plasma contains neither anti-A nor anti-B antibodies, it can be transfused to patients of any ABO type. For that reason, AB plasma is considered universal plasma and is often prioritized in trauma and massive transfusion protocols. Genetically, AB is regarded as the youngest major ABO group, emerging through historical mixing between A and B populations. The additional absence of the rhesus D factor further narrows its global distribution. If you carry AB negative and become pregnant with a rhesus positive fetus, your immune system may recognize the rhesus D antigen as foreign. Without preventive care, antibody formation can lead to hemolytic disease of the newborn. Today, anti-D immunoglobulin effectively prevents this immune reaction in most cases. AB negative is rare, clinically important for plasma donation, and dependent on a limited donor network. A negative. You represent roughly 3% of the global population, with higher prevalence in parts of Europe and lower frequencies in Asia and Africa. The defining biological feature is the presence of the A antigen combined with the absence of the rhesus D factor. For transfusions, this means compatibility is limited to A negative and O negative red cells. Compared to positive types, the donor pool is narrower, increasing the importance of stable donation programs. As donors, individuals in this group can provide red cells to A negative and AB negative recipients. The plasma contains anti-B antibodies but no anti-A antibodies, allowing certain compatible plasma transfusions without universal compatibility. Evolutionary research suggests that the A antigen increased in frequency as humans transitioned to agricultural societies. In densely populated settlements, altered immune responses linked to type A may have offered selective advantages against certain bacterial pathogens. If you carry A negative and are pregnant with a rhesus positive fetus, fetal red cells entering your circulation can trigger anti-D antibody formation. In subsequent pregnancies, these antibodies may cross the placenta and affect the fetus. Routine administration of anti-D immunoglobulin has made this complication largely preventable. B negative. Your blood type ranks among the least common worldwide. Only about 2% of the global population carries B negative, and in some regions it is even rarer. Red cells in this group display the B antigen while lacking the rhesus D factor. In clinical settings, compatibility is restricted to B negative and O negative red cells. Hospitals monitor these units carefully because replacement options are limited. As donors, carriers can support B negative and AB negative recipients, a small but critically dependent group. The B antigen shows a distinct geographic distribution, with higher frequencies in Central and South Asia and lower frequencies in Western Europe and the Americas. Genetic evidence links this pattern to ancient migration routes and regional adaptation. If you carry B negative and become pregnant with a rhesus positive fetus, immune sensitization may occur without preventive treatment. Anti-D immunoglobulin has largely eliminated this risk in modern obstetrics. B negative is rare and medically dependent on a narrow donor base. Across these types, a clear pattern emerges. Rarity reduces your margin for error and narrows your circle of compatibility. For some blood groups, survival depends on a very small network of donors. Blood type also defines flexibility. For millions of people worldwide, the decisive difference lies in how many options exist when seconds matter. A positive. You're part of one of the largest groups in the system. Around 30% of the global population belongs to A positive, making it the second most frequent type. Red cells in this group express the A antigen together with the rhesus D factor. This allows reception of A positive, A negative, O positive, and O negative red cells. The compatibility range is broad, making transfusion management relatively straightforward. As donors, individuals with A positive blood can provide red cells to A positive and AB positive recipients. Its prevalence ensures steady hospital reserves. From an evolutionary perspective, type A expanded as populations shifted toward agriculture. Some epidemiological data suggest non-O blood types, including A, are associated with slightly higher thrombotic risk compared to type O, illustrating how evolutionary trade-offs persist in modern populations. A positive is common, widely compatible, and structurally important in healthcare systems worldwide. B positive. You belong to a group that sits between rarity and prevalence. About 8% of the global population has B positive blood. Its red cells express the B antigen along with the rhesus D factor. Compatibility includes B positive, B negative, O positive, and O negative red cells. The range is moderate, broader than negative types, narrower than O positive. As donors, carriers support B positive and AB positive recipients. Regional variation in frequency can influence supply stability in different healthcare systems. The geographic distribution of the B antigen reflects ancient migration patterns and environmental adaptation over thousands of years. B positive contributes to maintaining diversity and resilience within the global blood supply. A B positive. You sit at the widest end of the compatibility spectrum. Fewer than 3% of people have AB positive blood. Red cells display both A and B antigens along with the rhesus D factor. Because no anti-A or anti-B antibodies are produced, individuals with AB positive blood can receive red cells from any ABO and rhesus group. This makes them the universal recipients in transfusion medicine. As donors, however, their red cells are limited to AB positive recipients. The plasma does not provide universal compatibility in the same way AB negative plasma does. Genetically, AB represents the youngest major ABO group, emerging through historical intermixing of A and B populations. A B positive offers the widest receiving compatibility of all blood types, while remaining specialized as a donor. Your blood type reflects your ancestry, determines compatibility, and defines your place within a global network of people who may never meet, yet still save each other's lives.